On this reaction, we already have the Kc written out. It's one you've seen before, and you can tell that the 2 right there is why that's squared, and nothing else has any coefficients, so these 2 ones don't have any values in there. So this part's really, really easy. All you're going to do is just make sure you pair up the numbers correctly, and then you're going to plug them in. I have a tendency to want to make sure and just do the ones that have the different exponents. I like to do those first, or sometimes I just always fill in the top numbers. So you may develop a preference for how you like to do these. But for example, that's HI and that's HI. If you have a tendency mixing up numbers when you put them in problems when they look like this, you can always grab a colored pencil or something and color code it right before you put it in just to make sure. And that might be a solution also. So I'm just going to plug in that number, 2.0, and it's going to be squared. And then for the bottom numbers, these 2 don't have exponents on the bottom, so in all honesty, it won't matter exactly where I put them, but you should still be vigilant because you never know, you may end up in a situation where some of those do have numbers. So that's 1.5 times, and then the remaining one, the 0.91. Those are all molarity. But the thing about Q is that whoever decided to make these different K charts, they decided that K was unitless. And so if K is unitless, then we're also going to say that Q is unitless. Now, I know you're looking at this and you're like, well, yeah, I can see that the M squared cancels with the M, so it's unitless. But there are plenty of these where you might have ended up with this combination with an M and an M. And so then it looks like it's M to the -1. And then you might have another combination where the top number is cubed, so then it's M. And just for simplicity's sake, and because we all understand how the formula is being filled in, we always express Q as being unitless, as well as K. So don't worry about the units on that one. So I've got 2.0 squared, and then divided by 1.5, and then divided by 0.91. So this value is 2.9, and this is just multiplying over in here, and so that has 2 sig figs, that has 2, that has 2, so I rounded my number so it has 2. Most of the time in your problem it will tell you what it can be, but this Q this range of the kinds of numbers that Q as well as K can be, it can be a huge range. I mean, you could be as small as 1 times 10 to negative 50th, all the way up to times 10 to the positive 46. So these numbers can be a huge range. So don't let it freak you out. If you get for AQ or AK a really, really, really tiny number or a really, really huge number, that's okay. The other thing I was going to mention is that you'll notice that I don't have an EQ written right there. If I had that EQ there, then that's your key that you are not solving for a Q value, which Q could be anywhere in the problem. You are solving for a K value. So the values have to say EQ, or it has to use the phrasing at equilibrium. And that's how you know you aren't solving for Q, you're solving for K. And again, it works the same way. You will have some videos coming up where you see that exactly. It's going to work the exact same way, and it'll feel like a repeat of information. But hey, easier repeat information can be nice every once in a while when you're in Gen Chem 2.